Assalamualaikum warahmatullahi wabarakatuh and good evening. My name is AFIFF NAUFAL bin Muhammad BURHAN and my metric number is B0920101141. Now we are going to present our assignment, which is Conduction Graphical Analysis on Heat Transfer. Okay, for introduction, what is conduction of heat transfer? Conduction is defined as the process of energy transfer from one medium particle to another in which the particles are in direct contact with each other. Conduction heat transfer in gases and liquid is due to the collision and diffusion of the molecules during their random motion, while heat transfer in solid is due to the combination of lattice vibration of the molecules and the energy transport by free electron. Conduction happens from a surface with high temperature to another surface with lower temperature. The one-dimensional heat equation for steady conduction is known as a Fourier equation on conduction and is given as Q dot equal to negative Ka delta T divided by delta S. K for thermal conductivity, A for area of surface that is exposed to heat, delta T the temperature difference, and delta L for distance heat travel. Okay, for Fourier's law. This law states that the time rate of heat transfer through a material is proportional to the negative gradient in the temperature and to the area, at right angle to that gradient through which the heat flow. Okay, what is objective of this assignment? To create two different fin surfaces according to our creativity by SolidWorks software. To perform heat transfer simulation process using SolidWorks software on the fin surface. To compare two different heat sink design in terms of heat transmission. Okay, what is defined of heat sink? Heat sink is a component that increases the flow of heat from a heating device. It achieves this by increasing the working surface area of the device and the amount of low temperature fluid flowing through it. How does a heat sink work? First, the source generates heat, and second, heat transfer away from the source. Heat distributed throughout the heat sink, and last, heat move away from the heat sink. Okay, that's all from me. Thank you.
My name is Muhammad HAIKAL bin ABDUL. My metric number is B0920100015. I'm gonna present about this design, which is design 1. This design was made from alloy steel. We designed the fin base with size 40mm width and 40mm length. The height from fin base to the top of the fin surface is 22mm. As we can see, we make this design with 18 fin. The thickness of each fin is 1mm and the distance between each fin is also 1mm. Now I will continue with the result. Based on the simulation that have been done, we applied 30 degrees Celsius for ambient temperature. We also applied convection coefficient, which is 5.03. Then we apply heat power with 31 watt. We can see that the highest temperature for this design is 333 degrees Celsius, which is the red part, and the lowest temperature is 318 degrees Celsius, which is the blue part. The mass density is 7,700 kg, thermal conductivity is 50 watt, and specific is 460 joule.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HAKIMI bin AZHAR. My matrix number is B0920100418. I will present my part for design 2. This is a dimension part of the design 2. As you can see, the thickness of each of the fin is 1 mm and height of the fin is 20 mm. This thickness of the base is 2 mm and fin base size is 40 width times 40 length. So the material of the we choose is alloy steels, and fin amount the design 2 is 110. Alright, okay, this is a result. For my design 2, this is a light circle shape with the material of alloy steels. The ambient temperature is 30 degrees Celsius or 303 Kelvin. The fin base size is 40 times 40. Convection coefficient is 5.03. The average heat flow is 1500. After I apply heat power 30 watt, we choose 30 watt at the bottom, we can see that the base is on hot side, that's mean in red shade, and on top of the fin is blue shade with is the cool side. So the maximum temperature is 282 and the minimum temperature is 257. The difference of the maximum and minimum temperature is 25. The mass density we get is 7700 kilogram, and the thermal conductivity is 50 watt, and the specific heat is 460 joule. So for me, the design 1 is most better than the design 2 because the different temperature at the design 1 is less than the design 2. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is AZZIM HAIKAL bin Abdul RASHID. My matrix number is B0920102882. Today I'm going to talk about the discussion. So for the first, through the design concept, radial heatsink design has a better airflow and smoother due to the more numerous and orderly arrangement of the fins compared to the heatsink design. Secondly, in terms of temperature, the second design suggests that it can rid of heat more. The number of fins indicates the exposed surface. It leads to more heat removal compared to the first design. The first design implies that the efficiency for it to get rid of heat is less. Next is the rate of heat transfer is higher if the fin is thinner. Fourth, fin spacing will give the effectiveness in heatsink. The smaller space between fins, the greater the effectiveness. And lastly, the advantage for the first design is in terms of cost. The less fins means the less the cost will be used, but the effectiveness against temperature is less because of the number of fins is less. Similarly, with the second design, which is radial heatsink design, the advantage is effectiveness in more effective heat conduction, but the disadvantage is due to this, the cost value is quite high because to build the more fins, it will use the more high quiet, the more price. Thank you for me.
Bismillahirrahmanirrahim. My name is MOHAMMAD ROSLAN with matric number B0920100310N. And now I will explain about the completion. From this assignment, we know that heatsink design 2 is a lot better than design 1. This is because the thermal range for design 2 is between 287 degrees Celsius to 282 degrees Celsius if compared to design 1, which is 318 degrees Celsius to 323 degrees Celsius. Design 1 have a good efficiency of conduction heat transfer due to it can heat more faster between each fin. From here, the amount of heat transfer depends on its driving mechanism and the resistance involved in the process. Then, the maximum of heat of the fin is the ideal situation that is used for evaluate for the efficiency of the fin. The fin arrangement of design 1 is much better if we compare to design 2 because it can give more airflow to it. We can see that design 1 have a better arrangement for the fin so that the airflow can go through it. And lastly, we are able to learn and draw the heat sink with the same dimension and different design through the SolidWorks. And that's it. Thank you.